So, okay, maybe my previous words about anyone having access to any IP frightened you, because, you know, if anyone can call the storage put API on my computer, I wouldn't be really happy about it, because one morning I get up and I see a terabyte file put into my MacBook, and it has not so much gigabytes left there, and I have no free disk space, and it's and it could be worse than that. So we have to protect our APIs. We have to manage the authorization. We have to be able to say that these people can use this API, and these people can use only this API. How is it done? We already seen the Tetraplex. But okay, I'm going too far. So the first thing, every service internally has an access to this function. You can always get call parameters from any service in any function, and you will get security metadata that will contain information about why, where something happened, and everything scrolled. You will have information about who sent the request. That's init peer ID, as we see in person science. You will be able to know who has created the service, who's the service creator or owner. And for example, this way you can do a check against if the current caller is an owner of the service. But you have more info than that. The get call parameters function, it returns the following structure. It has the following fields. So the current call initiator, the current service ID, if you need to check against it, for example, if you want to check that it wasn't redeployed or something. The ID of the service creator, so you can know who created the service. The ID of the current peer that hosts the service. So it's basically the ID of the node that you have deployed the service to. Current particle ID for deduplication of requests, to be able to implement exactly once semantics, for example, to be able to make idempotent queries and stuff. And the most crucial, most interesting part is Tetraplex. So imagine we have implemented this function isOwner in one of our services, right? It returns a Boolean, true or false, no information about whether, no signatures, nothing. So why trust that information? Imagine we have a script that calls isOwner and returns and gives that information to other function. Would you believe it? Like if someone gives me, I am the owner equals true, and that's the authorization. No, because that data could be easily hijacked, right? Anyone can emit a true result into script. I can put true into data and just feed here a true value without going to isOwner, without calling isOwner function here. Okay. So why believe it? How to make sure that this value, this true or false, comes from the correct function on the correct service? Okay, I have 20 minutes left. I will do it in 20 minutes. So here where Tetraplex come into play. So for each argument that is passed to the as an argument to our function, for example, we want to extend storage put with check of authority, to check that the only owner can write files to the file system, for example. Then when we do this, when we call put function with those three values, for those three arguments, the following happens. With each of the argument, we have a corresponding security tetraplet. So for each of these values, we will have a single tetraplet that says where this value comes from what node, from what service, from what function name, and was it modified in any way by JSON path. This way, what we can do, we can store the information about which function to believe. So owner can set the following information, that storage put should only believe true or false coming from the auth service on that node from the function IsAuthor and without any JSON path applied whatsoever. And if we are to call the storage put function with those arguments, we will see that we have this tetraplet, that this data comes from that node, from that service, from that function, and it wasn't JSON path applied whatsoever. So, and we can implement IsAuthenticated function. So we can implement put function in this following way. We receive IsAuthor, right? And we call IsAuthenticated, passing a simple Boolean value there. And if it's not authenticated, we return simply false, meaning that put didn't succeed. So inside the IsAuthenticated, we get the security meta information. We get the first tetraplet for, we know the first argument to the function is IsAuthor. And we check that this tetraplet is correct, that it's a correct service ID, it has correct function name, and it has no JSON path applied to it. This thing is implemented in the project called Fluence. It's a CRGT-based editor where you can sync different the text between different tabs. Like this. You can open this link with your friend or in several browser windows, and it will sync the contents. So inside, it uses the following logic, almost the same logic, to authenticate users. So only owner of the service can add users to that editor, right? It makes sense if I don't want anyone to do anything with my text that I myself deployed and I editing it with my friend. I don't want anyone to interfere with that. So let's try to see it in action. Let's go to Fluence.
Alexey, I just thought I'd intercede there because we have actually we have a hard stop at 7:30. Okay. So okay, my thought was that maybe there's, because since there are still people in the audience, you'd like to share a link and continue the discussion there. I don't
maybe end here with going through documentation. Do I have a few minutes?
Yeah. Just you've got 5 minutes basically.
Okay, okay, 5 minutes. Great. So cool. I will do that in 5 minutes.
Cool.
So go to Fluence services README, follow it, and deploy services on your own and see how it works. You will see that in order to use the Fluence app, you have to first set tetraplet. So as an owner of the Fluence, as one who deployed it, you have to say to it which data to trust, which JSON path to trust, which function is correct, which service is okay, and so on. You have to do that. So the service knows who to trust. Okay. And well, if you, and here, after you've done all of that, you can try it by running add message scripts, and you can just follow README here in the services of the Fluence. It tells you can just follow the steps. So if you are to use a wrong JSON path, for example, you will have the following error, that JSON path was expected to be like that, and JSON path actually was like that. So if data is forged from in some way, or it comes from a different source that you didn't allow, it will fail. You can check against it. You can check the authenticity of the data, its origin. It kind of like a cross-origin request policy. That's what we were inspired by. So it's kind of like that. Okay, so the network is live. We have a dashboard that shows all the services running on the nodes on the testnet. We have documentation here that overviews the language. It overviews how to develop services, how to launch your own node, the structure of the language, what built-in services you're able to use. There are plenty of them. It talks about the authorization in detail and explains different things. It has extra resources with YouTube talks and stuff. It has links to our Telegram, to our Discord, to the dashboard, and to discussions on GitHub. Please use it. It's a really nice way to discuss and to share your knowledge, to reuse knowledge. Reusage is the point of difference. So here's the dashboard. Dashboard contains a few of the future blueprints. It shows nodes that are in the testnet. You can see that I was saying that the third node is the most used one. You can see that it has almost 400 services deployed into it. Okay, so play with it, look for it. And we have a lot of examples in the example repository here. You can find all of those links in this link. I will post again in the Zoom in a moment. And well, play with the Fluence. Develop on it, hack, create Calendly calls with us, join the Discord, join Telegram. That's it.